As you hear these words, invisible waves are racing through Earth's ionosphere. High-frequency radio waves, 3 to 30 megahertz, the frequencies on which pilots over the Atlantic speak with air traffic controllers, on which ships in the Pacific send distress calls. But in this moment, now as you listen, these waves are bouncing back, being absorbed, vanishing into nothing. The reason lies 150 million kilometers away.
12 hours ago, the sun exploded. Not once, twice.
Within 5 hours, our central star fired 2 of the most powerful eruptions it is capable of producing. X-class flares, the highest category. The first struck the Americas, the second hit the Pacific. Both extinguished communications like a light switch. But here is what's remarkable. This was not a random event. This was not an isolated eruption. This was an announcement. 17 hours, 34 minutes Coordinated Universal Time. November 4th, 2025. Sunspot region AR4274. A dark spot on the sun's surface, larger than Earth. A vortex of charged particles trapped in a cage of magnetism. And then the break. Magnetic field lines snap, plasma is heated to millions of degrees, x 1.8. That means 18 times more intense than the threshold for the highest category. NASA's Solar Dynamics Observatory records everything. A massive arc of plasma, 100,000 kilometers long, 8 times Earth's diameter.
The radiation moves at the speed of light.
8 minutes and 20 seconds later, it strikes our planet. 12:34 Eastern Standard Time. The sun-facing hemisphere, North and South America. In this moment, something invisible happens 70 kilometers above your head. The ionospheric D layer, where solar radiation normally gently strips electrons from atoms. But in this moment, nothing is gentle. X-rays and extreme UV radiation hit the upper atmosphere like a hammer. Electron density rises by orders of magnitude. Instantaneously, radio waves in the high-frequency range hit a wall of charged particles. Every radio wave is systematically dismantled, wave by wave, until nothing gets through. NOAA categorizes it as R3, strong, the third highest level. A pilot over the Atlantic. Radio contact cuts out, no connection to air traffic control. A cargo ship in the North Atlantic. The high-frequency connection to the Coast Guard fails. Amateur radio operators in Brazil try to make contact with North America. Nothing, only white noise. For 47 minutes, half the world is radio silent. And the sun is not finished.
22:00 UTC, 5 hours later.
This time, the eruption doesn't come from AR4274. It comes from the sun's southeastern limb, a region just rotating into view, still half hidden. NOAA gives it a provisional number, possibly AR4248. And from there, X1.1, again, R3 warning level. Again, complete high-frequency blackout over the Pacific, New Zealand, Eastern Australia. For 51 minutes, the other half of the world is mute. But while we lose the radio waves, something far more dangerous happens in space. SOHO's coronagraphs show it. 2 enormous structures detaching from the sun, each carrying approximately 1.6 trillion kilograms of ionized plasma, more than all Earth's oceans combined. These are not simple gas clouds. These are magnetic structures, flux ropes, twisted magnetic field lines wrapping around a central axis. Speed, 400 to 1,000 kilometers per second. NOAA's preliminary trajectory calculations are clear. Both CMEs miss Earth directly. But the outer flanks might graze us. And there's something else on the way, a high-speed solar wind stream. If the CME flanks interact with this stream, we get a compound structure, more complex, more energetic. Arrival time at Earth, November 6th to 7th. Tomorrow, maybe tonight. NOAA issues a warning, G3 storm possible, strong, November 4th. For most people, an ordinary day, but for solar physicists, this date carries a shadow. November 4th, 2003, exactly 22 years earlier. On that day, SOHO registered the most powerful solar flare in modern history. An X flare so intense it overloaded the sensors. The measurement stopped at X28, but the true strength, at least X40. The Halloween solar storm event, the sun at the absolute maximum of its fury. Satellites were permanently damaged, transformers in Sweden burned out, astronauts on the ISS had to shelter in radiation-protected modules. Aurora were visible as far south as Texas. And now, 22 years later, another X-flare on November 4th. Physics knows no anniversaries, solar storms follow no calendar. But the parallel is uncanny, as if the sun is reminding us, I was here before, I can be stronger. To understand what happened on November 4th, we must go back 3 weeks. Late October, a massive sunspot region appears, designation AR4246. In its first passage, it produces 90 C-class flares and 27 M-class flares, one of the most active regions of solar cycle 25. Then it disappears at the northwestern limb. The sun's rotation carries it to the far side. For 14 days, it's invisible. 14 days during which we don't know what's happening to it. During these 14 days, spacecraft observing the sun from lateral angles register massive CMEs shooting over the limb. Venus is hit twice, on October 23rd and 26th. ESA's plasma probes measure intense magnetic structures, high energy density. AR4246 didn't rest on the far side. It exploded again and again. And then, early November, it reappears with a new number, AR4274. But it's the same region, returned, still active. November 3rd, AR4274 fires an M5 flare, then 4 more M-class flares, 12 C-class flares. The magnetic configuration beta-gamma, high complexity, unstable. November 4th, 1734 UTC X1.8. But the second X flare, 5 hours later, comes from AR4248, the southeastern limb. 2 active regions, both returned from the far side, both exploding. This is not coincidence, this is a pattern. Here is the fundamental problem. The sun rotates with a period of about 27 days at the equator. Half the solar surface faces away from Earth at any time. For 13 to 14 days, we see nothing. During these 14 days, anything can happen. New sunspots can form, magnetic complexity can increase, giant CMEs can be launched, and we know nothing about it. AR4246 was on the far side for 14 days. It exploded at least twice strongly enough to hit Venus. We only saw the tips rising above the solar horizon. What did we miss? Which flares didn't we see? How much magnetic energy built up? We'll never know, because we couldn't look. September 1st, 1859, British astronomer Richard Carrington observes the first documented solar flare.
18 hours later, KL.
The resulting CME hits Earth. Aurora visible as far south as Cuba. Telegraph lines catch fire. The entire global telegraph system fails. The Carrington event, the benchmark for solar violence. Today's estimates. A comparable event would catastrophically impact modern civilization. Power grids would collapse for weeks. Transformers would burn out. Replacements take months to years to manufacture. Satellites would be permanently damaged. GPS would fail. Communication systems would collapse. Economic damage, trillions of dollars. Complete recovery, more than a decade. And here's the problem, we know such events will occur again. July 23rd, 2012, a Carrington-class CME raced through Earth's orbit. 9 days too early. Had Earth been at that point in its orbit 9 days earlier, it would have been directly hit. We were lucky, pure blind luck. The probability that a Carrington-class event will hit Earth in the next 10 years, approximately 12%. 1 in 8. Solar cycle 25, the official forecast, a weak to moderate cycle. But actual activity exceeds predictions, significantly. Some scientists speculate cycle 25 could become comparable to cycle 23, the cycle that produced the Halloween event of 2003. And we're not at maximum yet. The peak lies ahead, somewhere in the next 6 to 12 months. What we're experiencing now, AR4274, AR4248, the double X flares, this is the preparation. This is not the climax. November 6th, 2025, today, AR4274 is still there, directly Earth-facing, still unstable. The potential for more X flares is high. AR4248 CME is on the way. Arrival tomorrow or the day after. And somewhere on the far side, on the half we cannot see, things are happening that we know nothing about. In 13 days, this hidden side will become visible. What waits there, we'll find out then. NOAA issues warnings. Satellite operators are notified. Power grid operators increase monitoring. Astronauts on the ISS prepare radiation-protected areas. Aurora hunters in Europe check forecasts. Will the storm be strong enough? For most of us, what's coming, if it comes, will be beautiful. Green and red curtains in the night sky. But for those who understand, these lights are a warning. A reminder that the sun has control, that 99.9% of the time, its fury goes in other directions. But 0.1% of the time, it aims at us. And in that 0.1%, everything is decided. Two questions remain. The first, were the two X flares an outlier, or the beginning of something larger? The next days will tell. AR4274 will give us the answer. The second question is more fundamental. Are we ready? Not for this specific storm, but for what will inevitably come, the unavoidable Carrington-class event, the storm that doesn't miss. Our civilization has become electrical, satellite-dependent, grid-networked, more vulnerable than ever in history, and the sun continues doing what it has always done. It rotates, it explodes, it sends its plasma clouds into the void. Most of the time they hit nothing. And sometimes, just sometimes, they hit us. Today, November 6, 2025, we wait
for AR4248's CME for its arrival, for the measurement of its magnetic structure.
AR4274 is still there, still capable of further explosions, and on the far side, on the half we can never see, something is happening that we know nothing about.
The sun has struck twice.
The question is not whether it will strike again. The question is, when? And next time, will it hit? The answer lies 150 million kilometers away, in regions that rotate every day, that can explode at any moment. We observe, we measure, we calculate. But in the end, we are spectators. The sun decides, and half of it remains forever hidden.